Okay, chain rule one. All right, so the chain rule allows us to compute derivatives, slopes of tangent lines, instantaneous rate of change, all the same thing. For functions like f of x equals all right, and so you don't need to have this memorized or know this for this class, but in pre-calculus you might have done compositions. And you can think of this as the composition of x cubed and x squared minus x, meaning that you take x squared minus x and you stick it in for x cubed and you get that back. Right, this is the composition symbol. Don't worry about it if you don't know it. We're not going to worry about that. All right, so there's an inside function and an outside function. So the insides and the outside. All right, the inside function here is x squared minus x. The outside function is x cubed. Okay, so when we do this, we're going to give x squared minus x the label u. All right, and now we want, and so it doesn't make sense to have an x cubed here. We're going to make this a u. Now notice that if you were to in fact insert u equals that in there, you'd get that back, right? Take this and put that in for u, you would get that back. Okay, now the chain rule says dy dx is equal to the multiplication of two different derivatives here. Okay, so you got your, let's see, so okay, du dx and dy. Okay, so it's the derivative of this guy with respect to u times the derivative of this guy with respect to x. Okay, so now you're leaving a little space for each of these guys here. All right, now let's go ahead and take some derivatives. Okay, if u is equal to that, then du dx from our power rule, we've got 2x minus 1. Here, the derivative of y with respect to u, dy du, is 3u squared. Okay, so this was dy du, that goes there. Oh, sorry, this is 3u squared. Okay, du dx, that's that guy, 2x minus 1. And we're almost done. Now, remember, this is dy dx. Another way to think of this is f prime of x. Leibniz notation, prime notation, both mean the same thing. This is the slope of the tangent line at x. Now, if we wanted to find f prime of 1, right, we could put a 1 in for all the x's, but we still would have a u. So we need to back substitute, what do we make u into? U is x squared minus x. So we have 3 x squared minus x squared, right? Because the u is that, so that goes in there, times 2x minus 1. And that's our answer. All right, let's look at a new one.
Okay, so let's say
f of x is now root 3x plus 2. All right, again, this is the composition of root x and 3x plus 2. It's like you take 3x plus 2 and you plug it in there, okay? Again, you're not required to know this. All right, so let's the inside function, let's see, we got 3x plus 2, the outside function. All right, remember we always give this a new name as u. What we'd usually call root x, we want to be able to put that, we want this to be the same as that, so we can put it back in there, we get that back, so we're going to have root u, which is u to the 1/2. Okay, so if u is 3x plus 2, du dx is 3. If y is u to the 1/2, dy du. Let's see, how do we do that, right? We pull down the 1/2. U to the 1/2 minus 1. So that's 1/2. U to the negative 1/2. 1 over 2 times 1 over u to the 1/2. U to the 1/2 is root u. So we have 1 over 2 root u. All right, let's put all of our stuff in there now. So dy du, so we found that right there, dy du, 1 over 2 root u. Du dx is a 3. That's 3 over 2 root u. Now what's root, so now what's u? U is 3x plus 2. So this is 3 over 2 root 3x plus 2. That's our answer. That's the slope of the tangent line at x. If you want to find the slope of the tangent line at 3, go ahead and plug it in there. F prime of 3 would be 3 over 2 times root 3 times 3 plus 2. All right, let's do one more. Now, and this one is going to be a little trickier to find the inside and the outside. So the inside and the outside makes sense when you have parentheses or square root. So I mean, intuitively it makes sense inside, outside. Let's go with e to the x squared minus x. Squared minus x. All right, this is the composition of e to the x and x squared minus x. It's like you take x squared minus x there and you put it into there. All right, so the inside function, again, you don't have to know that, but it does help. So the inside function, u equals x squared minus x. Outside, y equals e to the u. Derivative of u with respect to x is 2x plus 1. Derivative of y with respect to u is e to the u. Let's see, so dy du, found that, that's e to the u. Du dx, found it right there. 2x minus 1. Don't forget to back substitute. We don't want two different variables there. That makes things more complicated. Right? We just want x's or t's or whatever our function is in terms of. Okay, u is, so we have e to the